So guys, long time no seen, but my name is Max and welcome to this video today. We're going to go create a simple tic-tac-toe game using JavaScript and HTML. So let's just start by creating a new file called tic-toe or something like that, .html, and inside of there just grab some basic HTML, set the title, tic-tac-toe, for now at least. And to make things a little bit different today, why not add the script tag to the head of the file this time. So inside of here, we start by declaring a window on load event or on load function. So you do it like this, we call it main. Inside of here, we'll create our canvas, our global canvas later, our context and other stuff, and we also call our init and the tick function for the first time here. So let's just create our init function and our tick function. And the tick function, it will just call itself using a window request animation frame for looping here. So it will look like this, and then we call two other function that we call update and render that we will create right here. So say update and function render, like that. So now we have the basic skeleton for our game, but we haven't actually created those global variables that we call canvas and context that we use for drawing and drawing. So we just specify the global variables right there, and then we say document create elements. So we create this canvas and context, but before we do that we set the width and the height, and let's set it to 200 for now at least, and let's get the context from canvas to the context, and then let's just append the canvas to the body. So if we open this up in a web browser, so let's see, and if we inspect elements on the page, we could see that the canvas has been added to the page. So that's good. So, but before we move on, let's add some styling to the canvas here. So we can use a style tag like this, and here we can specify different CSS styles for our canvas. So let's add a border maybe. Let's set the position to absolute, the margin to auto, and then all of the positions here to 0. So we set the left and right positions to 0 like that, and that should center it in the middle of the screen on most of the browsers. So cool. So what do we do from here? Well, let's create our simple tile class that we use for our graphical representation of the game here. So you say function tile like that, because that's how you specify classes in JavaScript. And for this one we'll use a little bit odd syntax, but yeah, it's quite good. I like it sometimes. So we just use these variables here that we have inside of this function. And then we say add methods that will be that we can access later using this keyword. So we'll have a update method on the tile class, and we'll have a draw method on the tile class. And the draw method will take a context as a parameter here, and for now it will just draw an image which I haven't specified yet, but that we'll call tile, and it will draw that at the X and Y position. So let's specify this tile object. So set it like this, and set that to the tile blank, and that we haven't created yet. So we say if the tile is null, so if this here isn't initialized yet, then this block of code will be called, and inside of here we'll create this blank tile, the north tile and cross tile and all the stuff like that. So to do that we need a second canvas. So I just call it like this. So we say document.createElement canvas again. And for the width and the height for this one, let's set it to 100, like that. And let's grab the context as well. So we say context, get context to the, like that. And for the fill style, we could use HTML5 colors. So let's use sky blue, because that looks quite cool. And for now, let's just create a blank tile. So for doing that, it's real simple. We just do a fill rectangle over the whole of the canvas, like that. And then we say that the tile blank equal to a new image. And then we set the source of that image to the data URL of the canvas, which is a method that you can get the data represented as base 64 string, which makes you can save like the state of the canvas at a particular moment, and that's what we do, and we save that to this image object here. And we just want to make sure here so that we actually set the tile here to the blank tile as well, because it's null up here. Then we must make sure that we set the tile equals to this blank tile right there. So that's it for now. So let's see if it works. So let's just create a simple test tile for now. So, but I will call that data since we'll use that variable later. So let's create that as a global variable. And then I create this data here as a new tile. And for the position, let's set it at 2020. And in the render method, let's just draw it. So we say data.draw, and draw it to the context like that. And hopefully now you should see a blue screen drawn to the canvas right there. So that's cool. It's working. So let's create our some other tiles here as well. So let's create the north tile. Spell it like that. So we just for consistency can just fill the whole thing again, even though it isn't necessary. But anyway, and we set tile north here to a new image as well, and let's set the source here in the same way. So we say to data URL like that. But the magic comes in here, where we draw the circle or the north inside of the tile. So we say context.beginPath like that, and then context.stroke, which is two methods that we can use to draw polygons to a canvas, and then we use the arc method to draw a circle. So at first two augments, it's the position or the center of the circle or the arc we want to draw. So in this case it's the middle of the tile, so 50-50. Then the third augment is the radius. So for that we use 100, since it's 100 pixels wide, and we divide that by 2, so 50, and then we want to subtract 20 to pad it 20 from the side of the tile, so to speak. So this should actually be 30 or something like that. So we can keep it 100 over 2 minus 20, or we could just say 30 like that. And then it is between which angles we want to draw the circle in radians. So we want to draw it from this 0 to 2 times mat.pi, which is a full circle. So that should give us the north tile. So let's see if that works. It didn't really. So string is not function. 79. Let's see here. 79. Fill rect, not fill styles here. So like that. Yeah. So here you can see that we have the circle drawn to the canvas. But maybe a bit too small to see here, so we can add, can increase the line width. So let's say 4 pixels, which will give it appearance like that. And then we can maybe change the stroke style as well, so it fits a bit better with the theme here. So let's set that to white maybe. yeah, that looks quite good. So that's it. So let's do the cross as well. So we can just copy this since it's quite similar. So just copy it down right here. Let's change this to cross, even though it's pretty obvious that it is the cross here. Let's change it like that. And instead of the arc, we want to draw 2 lines to make up the course. So to do that, we use the move to method and the line to methods. So we want to draw 2 lines, so we call this twice here, so move to, and lastly context of line 2. And as arguments here, of course, it takes the x and y position of where we want to draw it. So let's draw it from the upper left corner down to the bottom right corner, so 80, 80. That should be, if we pad it with 20 again. And then we want to draw it from the upper right corner, so let's say 80, 20, and we want to draw it to the bottom left corner, so that should be 20, 80, like that. So let's change this to cross here and see if that works. So yeah, we now have the cross to the in the middle to the onto canvas. But I really don't like the line capping here, so we can change that as well with a simple method call here. So or property change. So we can say context of line cap, and I like sort of like the round line capping here. So if you keep if you observe here now, you can see that we have square line caps, but when I reload the page, you see that now it is rounded line caps, which is exactly what I want this particular time here. Yeah, so that's it for all of the different tiles. But let's go back to blank for now, please. Yeah, but so basically what I want is to have a cool animation when we like flip the tile. So I will create this new method here that I call flip, and as an argument that will take which tile it should be. So you say tile equal to the next, like that for now. And then we also want to have this animation variable here that I'll set to 0 at the start, but when we flip it, we want to set it to 1. And then gradually in the update method, we want to check if the animation is greater than 0, and if it is, we want to subtract, let's say 0.02 from the animation a variable there to like yeah, to make the animation run here. So right, for now, let's just call the update method of our test tile. So say update like that, and let's just flip it real quick. So say data.flip, and we can say tile.north. And as you see right now, we just changed the tile because we haven't really implemented the animation yet. So, but let's do that. So we can start by saying here, so we say if the animation is smaller or equal to 0, then we basically just want to draw the tile normally here. But if it isn't, then we want to check here. So we want to say check if we want to take out a tile here, a particular tile, so let's call it T for shorthand here. And we want to check if the animation is greater than 0.5. Then we want it to like be the blank tile in the beginning of the animation, so you can think of it like a page flip. So first you don't see the back side of the tile, but then you only see the front, which is blank. But then you flip it gradually, and up till half in the animation you don't see the tile, but then after that you will see the next tile here that we specify here up here. So that should be it. So for now, let's just call the context of draw image again, just to see if it works here. So X and Y. So right now you can see that it should be blank a bit, and then it should be the circle on it. Here you can see that it blinks like that. But basically what we want to do is we want to shrink the tile in the X direction. And to do that, we can split up the tile in different columns and draw them separately. So we do that. So we say for var I equals 0, I is less than 100, the width of the tile, and y plus equal a resolution variable that we haven't created yet. So let's just do that. So we say var res, let's set that to 2, and this here will say so the width of each of the columns we want to draw. And the smaller the columns, the better the effect, but the more processing power it will require. So in order for it to like run well on the mobiles and other stuff like that, then we resolution value of 2 or 4 is probably good. Anyway, so we say it like this. So then we just say we draw an image again here, and we want to draw the tile, and we use all of the 9, I should say, arguments to the draw image method. So basically, the 5 first arguments specify where on the image you want to draw, which image and what you want to draw. So in our example, for x position, we want to draw it at I, y position, we want to draw it at 0, and the width, we want to draw it the resolution width, and the height, we want to draw at 100, like that. Then for the 4 methods that arguments that come let then is where on the canvas we want to draw it. So for example, we want to draw it at x, y position, of course. We want to draw it at the width of the resolution, for now at least. And not to forget here, so if you can see right now, we just see one small column of the canvas drawn like that. So we basically want to add the I here, so you can see here how it's drawn normally. And to shrink it, we want to sort of like subtract here with a value. So let's say 0 to 2 times I, and that should give us a 0.2 width of the tile like that. So I just realized here that we should really clear the canvas before we draw anything to it. So let's call it clear rectangle here. So 0, 0, canvas the width, canvas the height. Yeah, so here you can see that we. And why isn't that clearing? Yeah, that should be cleared. So that's strange. Oh, I forgot to call the return method. Man. Yeah. So here you can see how we shrink it in the x direction. But basically we want to have that dynamically changing here. We don't want to have 0.2 all the time. We want to have that dynamically changing with the value of the animation here. So let's call it p for now, and let's set it as a function of animation. So let's just use a linear interpolation for now. So say let's use it like this. And that should give us like that. So you can see here how it shrink. But basically we want it to shrink first and then expand again. So for doing that, we could use an absolute function or a quadratic function, if you will, as well. But anyway, so an absolute function of the variable x looks like this. And we can translate it in the x direction like that, and we can mirror it on the y direction. Like that, and to get it up over this again, we can just like add 1 to it. So this is sort of the function we want, but we want it to go from 0 to 1 and not from 0 to 2 here. So we say 2 times the variable to give us like this. So if we use this for our function right here for the p-value, you can see here that we'll get the effect that we want here. So say 2 times animation minus 1 plus 1, like that. And if we go back to the browser and reload the page, you can see that it first shrinks and then expands again. And to give it more of a page flipping effect, we also want to like translate it in the X direction depending on I here. So for doing that, we can just like add 50 times P as well. And you can see here, now we get this sort of like flipping effect in that direction. But this isn't enough, at least I don't think so. So we could also like change the height dynamically here as well. So let's say if we want to like subtract, let's say I times P times 0.2 here maybe. Let's add I times P times 0.4 here. So half, we subtract half here and we add twice the amount there. You can see that we get this sort of page flipping animation like that. But it is flipping, we should want it to like flip straight over and not back and forth like that. And I haven't really figured out a smart way to do that, but we can just like declare a new variable, call it J, like there, and then we can like say if the animation once again is greater than 0.5, then we want it to be I. We can actually want to have like I right here. When it is bigger, we want it to be 100 minus I to like invert it, and that should give us the full and if we change this to J here, of course, that should give us the full flipping like that, which looks quite cool in my opinion at least. And I decided that we should probably have it flip in the other direction. So let's see what that looks like. Yeah. So here we now have the finished flipping. So you can keep it like this, or if you are if you're really picky, you could add take 50 minus this stuff, take it back over here, and to give it more of like an even animation. So that is what it looks like. Now you can see that it's really even, and the tile looks like it's centered all the time, or you can keep it the way we had before here, and here we can see that the tile more looks like it's coming forward at you or something like that. But I will leave it like this, so we have this even flipping animation. Yeah, so that's it for the tile class, almost at least. So let's just draw all of the 9 tiles to the canvas. So doing that, we go up here to the knit method again, and instead of just making the data equal to one single tile, we can say here, we can say if data is null, so if it doesn't exist yet, then we want to initialize it to an empty array like this. Then we want to loop, so you say var I equals 0, I is less than 9. We want to create 9 tiles like that. Then we just push new tiles here to the canvas, and let's just flip the 0most for now. And we haven't set the X and Y position yet, so bear with me guys, we will do that soon. But first we will do the update and render methods down here. So for doing that, we could use this shorthand for loop where we declare I here to 9 like that, or the data.length if we want to be really like good here, good conventions. So we can use this for loop to loop through all of the indexes of the data array, and then we'll say the data at index I as updates, and then we do the same thing if I just can get my mouse position right here. Oh, come on, like that, and we change this to draw, with the context right there. And for now, yeah, so for the X and Y position, it's a bit tricky. So with X position, that will just be equal to the I modulus 3, like that. So the modulus of, so the, one second guys. Yeah, sorry for that. So I modulus 3, that will just give us the remainder of this calculation. So let's say I here takes values between 0 and 8. Since we declare the loop the way we did here, so 0 modulus 3, for example, will be equal to 0 because the remainder is 0. But if you have 4 modulus 3, that will give you the remainder of 1, because you can only divide 4 even by 3 once, and then you get the remainder of 1. So that's this whole modulus operator. And then we take that and multiply that by 120 to make the spacing correctly, and then we add 20 to like pad it from the left at the start as well. And then for the Y position, we floor our number here. So we take I divided by 3, this time to like give the right row of where we want to draw it, and this time here with 120 plus 20. And if we have done this correctly, we do see some more tiles drawn to the canvas, but we can't see them all because the canvas is too small. So let's change the width here. So we say 3 times 120 plus 20, like that. And that should give us, make us see all of the tiles. So we now have that done. So we will do one more thing in this video as well. So we will make it possible to like click on the tiles to make them flip, and it will be real simple. We won't change, or we can do that. Okay, yeah, enough talking. Let's do this. So let's get rid of that method call. So we want to flip that tile, and then we go up here to the main method, and we add an event listener on the canvas. So it's a canvas add event listener, like that, and we will listen for the mouse down event, and we want to call the mouse down method a function that we haven't created yet. So add event listener. Well, it looked like it's the right spell, but yeah, we'll see. So let's create that function. We can create it. Yeah, let's create it down here. We say function mouse down, and as an augment that is passed to it through this is the what do you say, the event. So we can say var L that equal to the event target element, so that should be the canvas in this case. Then we calculate the position, the X position and the Y position. That will just be the client dot X minus the element dot I will see here, sorry guys, 1 second. Yeah, the offset left for the X position, of course, and of course we want to call it on the event event.client y. So this gives us the X and so the client X and Y position give us the mouse coordinates inside of the window relative to this point up here, and then we subtract with the offset, like the top offset and the left offset, to give the translated click position inside of the canvas. That's basically what this does. So it's the element dot offset top, like that, and let's just log out the positions for now to see if it works here. Yeah, so let's see. offset left of undefined. One moment, guys. Be right back. Yeah, so I'm so stupid sometimes. This should of course not be target element, just target, to give it a red method here. So you can see here now, when we click here near the top left corner, that will give low coordinates, and when we click down here, we'll get quite high coordinates. And yeah, so like that. So that works at least. So basically what we want to do now is we want to calculate on which of the squares we click. And to do that, we can use this sort of reminder trick again. So you can say if the position in the x direction, modulus 120, is less than 20, so if we don't want to register clicks that is within the padding, and that goes for both x and y positions, so say like that. And then to get the index that we want to flip here, we can use this mat of floor like that, and then we do like, and that should give us the x tile we want to click, so in this direction. But then we can add to the index, we can add the floor value, the floored value of the y position as well. And that should give us like a 0 if you click here, 1, 2, 3, 4, 5, 6, 7, 8 when we click on these different fields here. So to prove my point here, we can just console.log the index that we calculated. So let's see here. So here you can see 0. When we click on this one, it should be 4. Oh, that was a bit strange. Oh, this should of course be times 3 here. Yeah. So that's 1, 0, 2, 3, 4, 5, 6, 7, and 8. And you see here if we click inside within the margins, it shouldn't be registered. So why is that registered? Well, that was a bit strange. Oh, or it should of course be and. Yeah. So now it isn't registered when we click inside of the paddings. And then basically what we want to check, you want to check if the data at the index, so, and we want to check if that is and if it's flipped already, then we also want to return, or we can say, can do two methods here. So we can say has data. We haven't created this method yet, but we'll do that soon. But if it isn't, then we want to flip it. So we say index.flip. And we want to flip it like, yeah, let's flip all with north for now. So let's create this data method. So you can do it, yeah, let's do it up here. So we say this dot has data equals function. Won't take any arguments, and that will just return if the tile is not equals to the tile not blank. Yeah, and let's use double equal signs there for that. So hope now when we click on a tile, you can see that it's flipped. And if we clicked on a tile we have clicked on previously, you see that it isn't, that it is staying the way it was. So that's cool. So I will do one thing, and then in the second video we'll implement an AI system and some other fixes and stuff like that. But for now, we'll just make this a game 2-player. And with the hard reset button here, when we reset by clicking on the reload button. So to do that, we just create this active, or we can actually call it, can do it up here. And let's call it player. And in the init method, let's initialize the player to the north player. And then when we are flipped here, we flipped not to the, flip to the player, like that, and then we set the player equals to set players equals to the tile note. Then we want to flip it, change it to tile cross. Also want to change it to tile note, back to tile note. So for now, when we click on stuff, yeah, we can see that we go through like circle. And now we are cross again, and yeah. Now you can see that we can play the game. And we can reload the page pressing this button here. So this is it for the first video. Sorry for the long video, and sorry for the bad explanation of some parts of it, but yeah, hopefully it was clear in some parts and get some use of it. Well, anyway, I look forward to see you guys in the next video. So thank you guys for watching. See you guys soon. Bye.